We're here today in the Chemical Fingerprinting Lab at GSI, taking a look at ASTM D5885 for determining the auxiliative inductive time of polyolefins by differential scanning calorimetry, along with ASTM D5885 for OIT determination at high pressure. On the left, you can see the DSC cell used for running an OIT test at a pressure of 34 kilopascals or 5 psi. And on the right, you can see the high-pressure cell used to run HPOIT at a pressure of 3,400 kilopascals or 500 psi. Today, however, we'll be focusing on the standard OIT cell for running these tests. To set up the test, first cut a 3.5 plus or minus 0.5 microgram square specimen out with a razor blade. Place the specimen into a sample pan. Alright, to load the sample pan into the DSC, first we pick it up with a pair of tweezers and very carefully place our sample pan onto the front scale of the DSC cell. Then we take a reference pan, which is of the same mass as the sample pan but empty, and place that onto the rear scale. Then we take our thermal lid, place that on top. Now we're going to take the metal shield and place that on top of there. Now we take the glass dome, which traps the gas within the DSC cell, and place it on top, making sure you have an airtight seal. At this point in our standard OIT test, it's time to introduce gas into the cell. We will use this flow meter panel to introduce 5 psi or 34 kilopascals of nitrogen gas at a flow rate of 50 milliliters per minute. One important thing to note is that you must wait several minutes after turning on this nitrogen gas in order to let any oxygen be purged from the cell. After waiting several minutes, we're ready to start. Alright, the test is now underway, as you can see by the red heater light which is just lit up. The first phase of the test is for the DSC cell to ramp its internal temperature up to 200 degrees C, thus melting the plastic. This is done at a rate of 20 degrees C per minute. As you can see by the continuously rising monitor temperature, the cell is doing that now. After we reach 200 degrees C, the next phase of the test will begin. The first isothermal track phase lasts 5 minutes and essentially sits the cell at 200 degrees C while submerged in nitrogen gas. As you just saw, we started a timer at the beginning of the isotrack period to successfully count the 5-minute duration. However, the timer function is typically handled by the DSC's software. We're just using the egg timer to make this easier to follow on video. As we wait the 5 minutes for the DSC cell to complete its first isotrack phase, we prepare for arguably the most important part of the test, marking the T sub 0, or the starting point for the OIT calculation. At this T sub 0, two things must happen simultaneously. The time since the beginning of the test must be recorded, typically read off the computer software, and the gas in the chamber must be switched from nitrogen to oxygen. Depending on your hardware and software configuration, these tasks may either be automated or must be completed manually. Here you see the 5-minute mark on the timer, marking our T sub 0 for this test. The gas is switched on the flow meter panel, making sure the pressure and flow regulators for the oxygen gas read as they should, 50 milliliters a minute and 34 kilopascals or 5 psi. The absolute time must be then noted. For this test, T sub 0 occurred 13.93 minutes after the cell began to heat up. Please note that our particular software reports in minutes to the decimal instead of minutes and seconds. After the T sub 0 is passed, the cell continues its isothermal track at 200 degrees C. This is by far the longest portion of the test. At this point, there is nothing to do but wait for the auxiliative onset to occur. For standard OIT, GSI sets the second isotrack to run for a duration of 300 minutes, as 5 hours is plenty of time to experience the auxiliative onset and subsequent exotherm for most HDPE geomembranes. However, a high-pressure OIT test will require significantly more time to experience its onset and exotherm, and well over 1,000 minutes should be allocated for the test after the T sub 0 is passed. However, if the technician does observe the exotherm before the DSC finishes its second isotrack, they are welcome to stop the test, as no additional data is needed after the exotherm. We are now looking at the reference curves for both the standard and high-pressure OIT tests. In the standard OIT test we are actively running, we just experienced the T sub 0 after switching to the oxygen gas. This point is located here on the standard OIT graph, and the corresponding T sub 0 is located here on the high-pressure OIT graph. The long horizontal portion of the graph is the isotherm, where the test is running currently. Please note the break in these graphs, indicating that the isotherm can be much longer than pictured above. Highlighted now is the exotherm for both graphs. As you can see, the heat flow ramps up to reach a peak and then begins to fall. Once the peak has clearly been overcome, the test may be stopped. Fast forward about an hour to the conclusion of the standard OIT test we were running. Here's the curve produced by the DSC's software. As you can see, it very closely resembles that of the OIT reference curves we saw earlier. We know the T sub 0 is 13.93 minutes, but we must now determine the T onset point, as both values are needed to calculate the OIT. To do this, we first extend the line of the isotherm to the right to create our baseline. Next, we draw the line tangent to the exotherm. The intersection of this tangent line and the baseline is known as our onset time, T sub onset. For our curve here, the T sub onset is calculated to be 60.84 minutes. After this, calculating the OIT for this membrane is extremely straightforward. Simply subtract T sub 0 from T sub onset, and the result is the value for this material's oxidative inductive time. These calculations are identical for both the standard and high pressure OIT. Again, this has been a demonstration of ASTM D5895 and D5885. Thanks for watching.